gravity because it's the only one we have, right? So now what will be that force of gravity equal to according to the Newton's second law? The mass of the object times what? Times the acceleration. But what is the only acceleration is acting on this object? Gravity. So we call that the force of gravity will be the product of mass times the acceleration due to gravity. This is what we call gravitational force or weight of the object. This is what we call weight of the object. So weight of the object is not the mass. The mass is mass. The weight of the object is a force, which is equivalent to what? What is a synonym for weight? According to the equation, what is a synonym for weight? What did I say? How is called the force?
Gravitational force.
Force of gravity or gravitational force is the same than weight. So weight is the gravitational force. So when you go to Publix, you measure your weight on the scale that is in the entrance to that, you are not measuring your weight. You are measuring your mass. What actually measures the scale is the weight, but that weight is calibrated. So what actually measures is the weight, but that weight, they don't put 900 Newton, 800 Newton, they put 80 kilograms or pounds, 70 kilograms, but this is painting. So somebody calibrated and said, you know, then let me not put 800 because nobody will enter to Publix. You know, for commercial purpose, they put the mass. They don't put the amount of Newton. Got it? So, but the actual name for that is weight. This, force of gravity. If I ask for the mass, you just get the weight, which is in Newton, and you divide by 9.8. You get the mass. Okay? Good. Which is what they do when they do a scale in kilograms. They paint, instead of, you know, times 10, they divide approximately by 10. And that's what they put there, by 9.8. This is the definition of weight or force of gravity. Always, the force of gravity will be pointing in which direction? Downward to the center of the earth. Always. So whenever you need to draw a diagram where you have to draw the force of gravity, that force of gravity will be pointing downward to the center of the earth in any situation. Good. This is the first force. The second force we need to know here is the force, normal force. The second mechanical force we will learn is what is called normal force. Normal force, which we can label Fn, sometimes you will label also N capital. In physics with calculus, it's more frequently to see N capital than Fn. It doesn't matter. Normal force is a force of electromagnetic nature. Where appears this force? When you are pushing down, the electrons here feel uncomfortable because they are out of equilibrium. They are out of their nature. When you are pushing down, they want to relax. So they have to rearrange themselves in order to get equilibrium again. So they will push upward in the same way that you are pushing downward to get that relaxation. So when they relax, they apply the force, and that electromagnetic force of electromagnetic kind, it will be called normal force. And why normal? Because always will be perpendicular to the surface. In order to have normal force, we have to have contact between two surfaces. So if there is no contact between the two surfaces, there is no normal force. So, if you have, for example, a poly, and you have a block here, and this is the ground, is the normal force acting on the block? No, because there is no contact between the surface and the block. So in order to draw normal force on the object, you have to have contact between two surfaces. And that is called contact force, normal force, or force exerted by the supporting surface. These are the different names you will see for normal force. Always will be perpendicular to the surface. So, if we have this like this, I have this here, in which direction is the normal force? On the razor, perpendicular to the surface, so will be like this. So the normal force will be perpendicular to the surface, like this. This is important. So if I am leaning against the wall, in which directions are the normal forces acting on me? One in this direction, one in this direction. So will be two normal forces acting on me because there are two surfaces making contact with me. Okay, so the net normal force will be the combination of both. We have to add the two vectors, which will be in this direction. All right, this is what we call normal force. Another force, so the second force we know is normal force. Other forces you will see in problems, pulling force by a person. So you will add that also in the diagram. And another one, which will be frequently seen, is the tension. When you attach a cord and you pull a cord, that will be called tension. The tension is the force that every element exerts on the neighbor element. But because they cancel in pairs, why? Because the Newton's third law of motion. Newton's third law. The Newton's third law of motion, we will prove it later. Stop. Okay, so if I get two scallops, that's one, alright, so it's the only one. Okay, so anyway, so the Newton's third law of motion said that if we have two objects, the force that object one exerts on the second will be equal in magnitude to the force that this exerts on this, but opposite in direction. So whenever a force exerts a force on a second object, the second object will exert the same force on the first. They will be equal in magnitude, but opposite in direction. We have to have two objects to apply the Newton's third law. The forces have to act on different objects. So, if I get two scallops, so you will see that no matter what I do, the force will be the same in both. As long as I extend it, I move one, I move the other, the forces will be the same on both scales. I don't have now, but we will prove that in a lab later. Okay, so this is the Newton's third law. How can I write mathematically the Newton's third law? If the force that on 2 by 1 will be negative, the force on 1 by 2. This means the subscript. On 2 by 1. On 1 by 2. They will be opposite in direction, and they are vector. But the magnitude, which is the absolute value of F21, will be equal to the magnitude of F12. When we will see very frequently in problems that when you have, for example, you have one object and another object, and I am pulling this. What will be the force? The tension force. The tension is the force on the cord exerted by every element on the neighbor element, but at the end we only label in one direction. So every time you have a cord, there will be a tension, but the tension always will be away from the object and along the rope, So if it's away from the object and along the rope, how can I draw the tension on this one? Will be this way, right? And how can I write the tension in this one, or how can I draw the this way? So by the action and reaction law, how this tension should be? The same. So this tension and this tension have to be the same. So the tension that one box is exerting on the other is equal to the other tension. Okay? So every time that you have two objects with the cord, you will have on each side tension. And those tensions have to be the same. This is an application of the Newton's third law. Good. Knowing that the three laws of motion, we are now in good position to start solving problems with the Newton laws. Let's start with the basic. So summarizing the laws,